Hey, welcome to part 4. Hopefully this is the last section. So next it wants us to look at solubility curves. So here's our solubility graph. Keep in mind that when you look at this, it's always based on 100 grams or 100 mils of water. So it's always sort of based on a beaker that has 100 mils of water. So be careful, you could get questions where it could say, well, what happens if we double the water? So it's 200 mils, and then you have to double your values if you use more water. So the first question is, which substances are considered gases? So gases are different than solids and liquids in that as we raise the temperature, their solubility goes down. So this substance decreases as the temperature goes up, and this substance. So there are, and that one. So there are three gases on this. At what temperature is the solubility of NH3 and KNO3 the same? So we're looking for when they cross. NH3 is here, and KNO3 is here, and they cross right there. So we go down, so it's approximately 28 degrees Celsius. Which substance has the lowest solubility at 0? Okay, so there's 0. This substance, which is KClO3, is only 5 grams at 0. So it's the lowest. Which substance's solubility is least affected by changes in temperature? So we're looking for the substance where the line isn't very steep. Look at this one. KNO3 is really affected by temperature. Look at how much it is steep. However, NaCl is barely affected. So NaCl is the winner there. Next, describe the relationship between pressure and water depth. So it's the opposite. Here's water, and so as you go deeper and deeper down in water, the column of water pushing down on you gets bigger and bigger, so pressure increases as you go down, so that this might be 70, 80, and by the time you reach this depth it might be 100. How is buoyancy of a liquid affected by changes in temperature? Let's come back to that. Let's use the picture. It says, use the picture, the substance the highest buoyant force to the lowest. So density and buoyancy are related, so these give us the density. So liquid Z has the highest density and therefore has the highest buoyant force. So it can push and hold up more substances. It would be easier to float an object here than in here. So this is the lowest buoyant force and the lowest density. How is buoyancy of a liquid affected by its changes in temperature? Remember, buoyancy is totally related to density. And so let's talk about density. So as a liquid gets colder, it gets more dense, and therefore it sinks because it's heavier, which means its buoyant force is stronger, so it has a stronger push, stronger buoyant force. So let's talk about floating. In cold water, you are able to float more objects because the density of cold water is higher. If we had hot water, let's say water at 60 degrees Celsius, it is less dense, then it won't float as many objects. So I hope this review helps you for your big chapter test.